Real quick, just want to remind you, what do you have next Tuesday? A test. Fantastic. All right. So running through this, we did get through the first six, correct? Yes, no, maybe. All right. Here's what we need to do. I know we did not do the last two, did we? Did we? All right. So here's what I need you to write. Okay. So let's look at the first example. It says comparing using one thing or equal sign. What are those two other signs? Greater than or less than, okay? So we need to be able to determine if a value is greater than or less than the other value. Well, here's the problem that we run into. Students, they see the number 56 and they see the number fixed. And naturally, what would you say there? Yeah, 56 is greater than 6, and duh, that makes common sense. But here's the problem. When you get in science class, we have units on the end of everything. And the problem is do our units match in this particular case? No, they don't match. So we've got to do something very important. This is what I need you to write down, okay? So make the units match. Make the units match. So in essence, instead of comparing apples to oranges, we're now trying to compare apples to apples or oranges to oranges. Okay? We always want to make sure that what we're doing, the units are equivalent, so you can make the comparison. But here's the best news about this concept. Does it matter which one you convert to which? No. You can do either one. You get to pick. That's the free side of this, is that it doesn't matter whichever one you want to do. Okay? So here's what I'm going to do. I'm going to come over here. I'm going to rewrite it like this. So it's 56 centimeters is something than 6 meters. Now, some of you already know the answer without having to do anything, and that's awesome, because distances are easy to visualize. But when you start getting into volumes and you start getting into masses, those are a little bit more challenging. Okay? So here's what I'm going to do. The first thing I'm going to do is I'm going to convert meters to centimeters. Now, I really should have already written this a different way, but that's fine. So actually, KHD bar DCM. So the first one I'm going to do is convert my meters to centimeters. So which direction, how many places would I need to move it? So I'm going from here, 1, 2. So 2 places to the right, correct? So 6 meters turns into 600 centimeters. Now this turns into a really easy problem. So what is true there? Okay, 56 is less than 600. Okay. Now, what if you said, well, I wouldn't have done it that way. I would have done it the other way. Okay, well, let's look and see. So this time, I want to convert the 56 centimeters to meters. Well, if I go 2 places to the right, the other way, well, how do I do this one? 2 places to the left. So it's going to be 0.56 meters versus 6 meters. And then what's still true? It's 0.56 blank than 6. It is less than. So now we know that this must be true. So let me give you a visual for just a second. Hang on. All right, so what is this I'm holding in my hand? This is a meter stick, not a yardstick. Okay? So in a meter, how many centimeters are there? 100. Okay? So in this 1 meter stick, where my finger is to this end, that is 56 centimeters. We cool with that? Now, 6 meters. How would I represent 6 meters with this thing? I need 6 of them. So visually, what's more, 6 of these or 56 centimeters in the one? 6 of these. Does that make common sense? Okay. So distance is a lot easier to kind of figure out than it is, but when you, like I said, when you start getting into volumes and you start getting into masses, it's harder to visualize than it is distances. All right, so what I want you guys to do is I want you to do the other one, 7 grams to 698 grams. Before you do it, I want to ask this one simple question. Let's look at both of these examples. Is it possible for either one of them to be equal to one another? In these 2 examples, 56 and 6, no matter how you move the decimal, will they ever be equal? No. In 7 and 698, will they ever be equal? Okay, so keep that in mind as you go through this. Okay, see if you can do the other one. All right, so here's my first question. How many, this is just a curiosity question. I'm kind of just want some feedback here. How many of you converted milligrams to grams? Okay, 1, 2, 3, 4, 5, 6. Okay. How many of you converted grams to milligrams? Okay, that's fair. All right, so let's do grams to milligrams first. All right, so if I want to go from grams to milligrams, which direction, how many places? 3 to the right. So 7 grams turns into what? 7,000 milligrams. Okay, and this is still 698 milligrams. Okay, and the other one, if we do it the other way, if I want to go from milligrams to grams, now I need to go 3 places to the left, so that turns into what? 0.698 grams versus 7 grams. So, will our sign be the same in all 3 cases? Okay, what way are we going to put the open sign? All of those, right? Okay, does that make sense? All right, good deal. So, next thing, let's move on to the next slide. Okay, you may have to turn that over. Do you? No? All right, what I want you guys to do is do number 1 through 9 real quick. 60 seconds. It shouldn't take you long at all. Okay. All right, Cole, start with you. What is the abbreviation for kilogram? Very good. All right, Cameron, meter. M, Hayes, gram. G, Dorian, milliliter. Real quick, did anybody put little m, big L? Interesting, okay? I've been asking that question all day, and that's what most people do. It doesn't matter. It's the exact same thing, but most people always do it this way. Well, fine. Matter of fact, that's kind of the habit that I'm in as well. Okay? All right, Jack, millimeter. MM. Liter, Natasha. L, everybody put capital L. Okay, seems to be a habit as well. Kilometer, Taylor. KM, very good. Sophie, centimeter. Very good. And Amari, milligram. MG, fantastic. Any questions on those? Pretty straightforward, right? Pretty simple. Go ahead. Yes. Is it? No, that's not on there. No, the base units? Okay, gotcha. All right, so what I'm going to do is I'm going to do these first 4 with your 5 with you guys. I'm going to do 10 through 14 with you, and I'm going to give you a chance to work on the rest of them. Okay? All right, so let me clear this. And we're going K, H, D, bar, D, C, M. I'm going to come in here and I'm going to write base unit. Okay? All right, Hannah Grayson, do me a favor. What's the first one? What's number 10? Okay, we're going to, did you say grams? Okay. All right, so Hannah Grayson, here's my question. Where are we starting on our ladder? Okay, very good. And where am I trying to get to? Base, very good. So which direction, how many places? Very good. Now, you don't see my decimal, but where is it? This is an important question, so before you answer that, I've had a few people ask me, I don't know where my decimal goes. I don't know where I have to put it. If it's a whole number value, if you can't see it, where do you always put it? Now, when you say the end, which end? The right end. That's very important that we know that if you don't see it and it's a whole number, that's where it goes. Okay. So Hannah Gracie, you said 3 places to the left. Now, here's an important question. How many significant figures are in the original written number? Okay. Thank you. There's only 1. So how many must your answer only have? 1. Hannah Grayson, so what should your answer be? Very good. Your answer is 2. Again, we want to make sure that our significant figures stay the same throughout this entire process. Any questions on that one? Okay. Josh, what's the next problem for me, please, sir? Number 11. Equals what? Meters. Thank you, sir. Okay. All right, so Josh, where are we starting on our ladder? Okay, so I'm going to start here. Where am I trying to go? The base unit, right? Very good. So which direction, how many places? Very good. So I'm going to just kind of go 1, 2, 3. But the problem is I don't have any numbers there, Josh, so what do I fill in? Fantastic. So what's your final answer? Very good. 104,000. Feel better. Okay. Any questions on that one? 104,000 meters. Okay? Real quick, throwing this at you. Write that in scientific notation. I hadn't asked that question yet today, and it just hit me. See if you can write that in scientific notation. Oh, man. Remember, there's one rule you can't break. Don't break that one rule. All right, what's that one rule that you cannot break? One real number left of the decimal. So it has to be 1 point something, right? Now, how many significant figures are in that blue number? 3. So I need 1.04 times 10. And how many times did you move the decimal? 5 times. Very good. Now, I want to just ask this to make sure we're all on the same page. Why isn't it not negative 5? Is the number bigger than 1 or less than 1? Bigger than 1. So it's going to be a positive exponent. Are y'all confident in that? No? Okay, we're gonna work on that some more. Okay? Alright. So, do you want me to show you how I did that? Okay? Alright, so we have 104,000, right? You don't see the decimal, so where does it automatically go if I need to put it? Okay, so I'm gonna put it right there. So the way I do this is I need to make one number left of that decimal. Well, the only way that I can move the decimal to get one number to the left of it is which direction? Left. So I'm going to go 1, 2, 3, 4, and then 5. So do you understand that part? Okay? Does that part make sense, the 5? Because I moved the decimal 5 places, that's my exponent. Is how many times you moved it. Yep. Okay. If I wrote... And again, I'm just making this up. I don't really know what this number is. But if I need one number left of the decimal, right? So I know it's got to be 2.04 something. Okay? So times 10. Let's just count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So times 10 to the 11. Okay? It's a great question. The way you know it's positive or negative, is this number less than 1 or greater than 1? Greater than 1. Anytime it's greater than 1, your exponent is positive. Okay? We mean the first number. That's your exponent is positive. The number, the whole value in expanded form is greater than 1. Okay, let me show you the opposite. What if you had 0.0000000000281? Okay? My rule that I cannot break is one number left of the decimal. Okay, so that means what's going to be my first? How far can I roll when I need to stop? I need to go to the 2, right? So you agree it's going to be 2.81. Okay, times 10, and this is the important part. Is this number more than 1 or less than 1? Less. So automatically we assign it a negative sign. Okay, so now we see how far we roll. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And 10. Okay, so 2.81 times 10 to the negative 10. Does that help others of you? Okay, better. Okay, so really that's all you're doing. If the number is less than 1, it's got to be negative. If the number is greater than 1, it's got to be positive, and you're just counting how far you're moving it. Okay. All right. So that's not the button I want. I want to go back here and clear this. As a matter of fact, go back to this because it's a little bit bigger. All right, Caleb, what's the next number that we're going to work on? I think it's number 12. Yeah, I think so. 10, 11, 12. Equals how much? Equals what? Meters, okay? All right, so Caleb, where are we starting on our ladder? Where are we starting on this thing? Okay, so we're starting with there. Where are we going? I know that, but where are we? Okay, so we're going to end there. So how many places, which way am I moving my decimal? 2, which way? All right, so right now I don't have a decimal on there. So where would I need to put it to start moving it? Okay, all right, so right there, so we're going to go 1 and 2. I'm going to put that thing right there. Now here's an important question. What is your final correct answer? Okay. Do we need the 0? No, you do not need the 0. The reason why you do not need the 0 is because the number as it was originally written, 480. Question, decimal point present or absent? Absent. Start on which side? The Atlantic side, your right side. Go to your first non-zero, which is what? 8. Count it and everything to the left. So there's only 2. Now look at that red number. Are there 2? Does that make sense? All right, good deal. Again, guys, you have to stop me. I don't know if you don't know unless you stop me. Okay? All right, next. Reagan, what's the next problem? Okay? So, Reagan, where are we starting on our ladder? Okay? And where am I going? Very good. So, how many places which way? To the right. So, what's your final answer going to be? Very good. 5,600. Let me ask this important question. Do you need to put the decimal on the end of that number? No. Leave it off. Because 5.6 is how many sig figs? 2. And as it's currently written there in blue, it is also 2 significant figures. So leave it alone. Okay? All right, Brad, last one. 8 what? Thank you, sir. Okay. All right, so Brad, where are we starting? Okay. And we're going where? Very good. So what's your answer going to be? Did he get that right or wrong, everyone? Wrong. Why did he get it wrong? What's got to always be in front? Very good. Okay. And again, I'm glad you said it that way, though. Okay. I'm not trying to, but I want to make sure that that's very clear. So I'm actually glad you said it that way. Please make sure you put that leader 0 in front. Okay. Are you guys to the other, just that first, 15 through 24. See if you can get all of those. All right. So this is going to be kind of rapid fire. And again, if you have an issue, I need you to stop me because I don't know that you don't get it unless you tell me, hey, wait a minute, can you explain that one more time? Like I said, I really wanted to bring some of you guys up here because of lack of time. I just want to make sure you have the right answers before we move on. All right. So number 15, 5 liters going to milliliters. You should have gone 3 places to the right. So you should have come up with 5,000 as your answer there. Okay. So we've got 5,000. All right, number 16, 198 grams to kilograms. You should have gone 3 places to the left, which means you should have gotten 0.198. Any questions on that? All right, milliliters to liters. That's 3 places to the left, and this is an important one. Make sure you pay attention to this one. 0.075. Did everyone get that extra 0 in there? Okay, good deal. 50 centimeters to meters. That's 2 places to the left. So 0.50. 5.6 meters to centimeters. That's how many which way? 2 to the right. So 500 and what? 60. Do you need that decimal point? Please. Okay. So just 560. Go ahead. Ah, very good. Cody caught me. Now, let's go back and let's look at this one. What's up? Okay, thank you. Now, so let's look at, that was the thing, and this was the original question. In the blue number, how many significant figures are there? 1. In my green number, how many are there? So how do I get it back to 1? Eliminate that last 0. If you put that extra 0 on there, very good. Thank you for catching that, Cody. Okay. All right, so again, I'm going to cross that off. We don't need that. All right, number 20, 16 centimeters to millimeters. How many places which way? To the 1 to the right, so it's what? 160. 2,500 meters to kilometers. That's how many places which way? 3 to the left, so it's 2.5. Very good. No extra zeros on that thing. Okay, 65 grams to milligrams. That's 3 places to the right, so it's what? Very good. 65,000. 6.3 centimeters to millimeters. That's how many places which way? 1 to the right, so it should be 630. And then the last one, 120 milligrams to grams. Yeah, my bad. I don't know why I added that 0. That was dumb. Sorry. So 63. And then 120 milligrams to grams, that's 3 to the left. So 0.120. All right. Any questions on any of those? Go ahead, Jax. Dadgummit! I promise to know how to do this. I'm just thinking. I'm trying to get to the next thing, and I'm going way too fast. All right. Last thing, real quick. Don't put it up. Stay with me. If you can do these, you can do any of them. One last thing I want you to do. Above this slide that says on the back, go ahead and write your story. Okay? I didn't write that in the right order. Yeah, flip it over. Okay? And I want you to also write this. So write what's in blue and in red. And see if you can go through and do these 6. If you can do these, you can do anything with metric. All right, guys, real quick, let's run through these. Make sure you got these right. Again, I know that you can move them both ways, and we're going to run out of time, so I want to give you the right answers first, okay? So I'm just going to move one of them to show you. So I know that 6 meters is going to be 600 centimeters. So that means that end is greater, okay? So I'm going to move decimeters to centimeters. That's one place to the right, so that's 536 centimeters. So what's true about that one? They're equal. Very good, okay? So 5 grams is 5,000 milligrams, which means that is greater, okay? Again, 5 grams is 5,000 milligrams. So again, that side is greater, okay? 1,500 milliliters or 1.5 liters, that is 1,500 milliliters, so they are equal. And then meters to centimeters, that's 2 places to the right. So that's 360 meters and 360 centimeters in that. Okay, any questions on that? Good deal.